Welcome to Lasea class. I am your teacher, Jan Lasea.
A blessed day to everyone! Today, we are going to learn sentiment analysis in machine learning. Sentiment analysis is a natural language processing that classify the text based on the mood or mentality expressed, which can be positive, negative, or neutral. Sentiment analysis is also known as opinion mining or emotion AI. The English word sentiment means feeling, emotion, response, reaction, attitude, opinion, outlook. Sentiment analysis is widely applied to voice of the customer materials such as reviews and survey responses, online and social media, and healthcare materials for applications that range from marketing to customer service to clinical medicine. The applications of sentiment analysis in business are the following: research and analysis of market trends, catering to customer satisfaction, decision making for investments, cyberbullying on social media and cybersecurity, business intelligence, employee satisfaction, marketing campaigns, crisis management for brands, politics, and banking. Text classification is the process of assigning text documents into one or more classes or categories. Text classification is also known as document classification. Natural language processing or NLP is a subfield of computer science that is focused on allowing computers to understand language in a natural way as humans do. Typically, this would refer to tasks such as understanding the sentiment of text, speech recognition, and generating responses to questions. Here are some applications of natural language processing, such as AI assistants like Cortana, Siri, Alexa, auto spell check on smartphones, predictive text or text completion, chatbots that handle customer service requests, information extraction, language translation, and sentiment analysis. Let us learn some basics of natural language processing before diving into sentiment analysis. Sentiment analysis classifies text data, not numerical data. Machine learning processes numbers, therefore you must convert the text to number when you train a sentiment analysis model. Vectorization is the process of converting text into numbers. The results of converting text into numbers contain a dictionary from the corpus of words in the training text and generates a matrix of words counts like the one below. So those texts will be counted, and then the results of the counted words will now be the converted text into numbers. Tokenizing text refers to splitting text into minimal, meaningful units. It is a method of breaking up a piece of text into many pieces or tokens, such as sentences and words. The word token is a piece of a whole, so a word is a token in a sentence, and a sentence is a token in a paragraph. For example, we have this sentence, "Hello world, it's good to see you. Thanks for buying this book." If we assume that sentence is tokenized in a paragraph, therefore we separate those sentences, and then those sentences will now be the tokens. If we separate those sentences by words, therefore a word is tokenized in sentence. Like for example, this array of words. Stemming is a process of extracting a root word. For example, the words fish, fishes, fishing are stemmed into fish. If we have a sentences or a paragraph, I like fishing, I ate fish, there are many fishes in pound, and then if we apply steaming, it will now be like this. I like fish, I ate fish, there are many fish in pound. Note that in natural language processing, English grammars like singular, plurality of nouns, and verbs are not recognized. Lemmatization is the process of extracting a root word by considering the vocabulary. For example, the words good, better, or best is lemmatized into good. The differences between lemmatization and stemming is that the part of speech of a word is determined in lemmatization. It will return the dictionary form of a word, which must be a valid word, while stemming just extracts the root word. Lemmatization handles matching car to cars, along with matching car to automobile, while stemming handles matching car to cars only. Lemmatization can get better results. For example, if we stem the word lives, it becomes now live. If we stem the word lives, it will now become live. If we lemmatize the word lives, it will now be live. If we lemmatize the word lives, it will now be live. Take note that lives is the plural of live. And another meaning of that word lives, which is a verb that means depart. So, lemmatization can get better results in some way. If we wanted to get the the matching vocabulary, lemmatization is what we will use. Stop words are the common words that carry no meaning or less meaning compared to other words or keywords. If we remove the words that are less commonly used, we can focus on the important keywords instead. For example, in the context of a search engine, if you search a query, how to develop chatbot using Python, if the search engine tries to find web pages that contain the terms how, the word to develop chatbot, using Python, the search engine is going to find a lot more pages that contains the terms how to than pages that contain information about developing chatbot, which is the main idea that we wanted to search. Because the terms how and to are so commonly used in the English language, we call them stop words. And then here are some more examples of stop words that are common in the English language. Like, for example, the letter A, and, the, this, able, either, else, ever, and, or, of, on, and many more. So we need to stop those words or we will not include them in our machine training. Let us learn some more basics of natural language processing. Beside removing those stop words, we will also remove punctuations. Punctuation does not add any extra information or value or meaning. Hence, removal of all such instances will help reduce the size of the data and increase computational efficiency. For example, if we have this paragraph of sentences that has punctuations, and if we remove those punctuations, it will lessen the size. And then the algorithm for machine learning will also be optimized or it will be efficient because we decrease the size of the data by removing punctuations and as well as stop words. The text feature extraction is the process of transforming what is essentially a list of words into a feature set that is usable by a classifier. The bag of words refer to those collected words that are placed in a imaginary bag that has a present feature from all the words of an instance. As long as the word is present in that list of words, therefore, it will be collected and placed in a imaginary container, such as a bag. For example, if we have a phrase or a sentence, the quick brown fox, therefore, we are going to collect those words, place it in a container or a bag, and then the result of the bag of words are the following. We have the word quick, brown, and then fox. The word the is a stop word that we remove. 1 indicates that it is true. 0 indicates that it is false. If that word is not cannot be found in the data set or in the pre-trained model, therefore it will be assigned as a 0. And then the probability of prediction of that response will be low compared to a word that has assigned a value of 1. The probability of 1 is high during the prediction process. The sample codes for sentiment analysis are written in Python programming language. Install the latest version of Python interpreter in this URL address for Windows. Let us implement sentiment analysis using the NLTK library. To install NLTK library, you must connect your computer in the internet. In your Windows operating system, run the command console and type the following command: pip install NLTK. The NLTK library has a pre-trained sentiment analysis model. In our Python code, we import the NLTK library from the NLTK. We import from that library. We import the class name sentiment intensity analyzer. The command nltk.download with this file Bader underscore lexicon will download the file Bader underscore lexicon.zip. And then once that it is finished downloading that file, it will be placed on drive C, folder users, subfolder admin, subfolder appdata, subfolder rooming, subfolder nltk underscore data, and subfolder sentiment. Once that it is downloaded, it will not be downloaded again. When you call twice or many times this command nltk.download, that Bader underscore lexicon.zip is the Bader sentiment analysis, which is the pre-trained sentiment analysis model. Bader is a lexicon and rule-based sentiment analysis tool that is specifically attuned to sentiments expressed in social media and works well on text from other domains. Finally, we will instantiate a sentiment intensity analyzer object and we will name it SIA. That stands for Sentiment Intensity Analyzer. Next, we will now test an example product review to determine the sentiment, to predict what is the sentiment of this product review. For example, the product review is the product is amazing. And then we store it to that variable review, and then we call the method polarity underscore scores, and then we pass as argument of that variable review, and then it will return now a level of confidence, like kind of a score that contains the three sentiments such as negative, neutral, positive. And then if we run this Python code and test that example product review, which is the product is amazing, it will display the following scores on the console window. The negative sentiment is 0. Neutral has 0.441. Positive is 0.559. We have a compound that this will be the score of that compound that we can determine the sentiment of that product review, whether it is positive or negative. that compound will get the highest score among the three. The highest score is 0.559. Probably it uses some formula to get that 0.5859, which is near to that. So, in this if statement, if we compare the score from that compound which is greater than 0, therefore, it is positive. If it is less than 0, therefore, it is negative. So, the product review, which is the product is amazing, according to the Bader sentiment analysis pre-trained model, the prediction is it is positive. Let us implement sentiment analysis using the scikit-learn library. To install scikit-learn library, you must connect your computer in the internet. In your Windows operating system, run the command console and type the following commands: pip install pandas, followed by pip install sklearn, or that is the scikit-learn library. The class support vector classifier, or SVC, of the scikit-learn library is what we will use to implement sentiment analysis. Support vector classifier, or SVC, is a powerful tool for classification tasks, particularly in situations where you have high-dimensional data or need to deal with nonlinear decision boundaries. The support vector classifier, SVC, is a type of support vector machine, or SVM, used for classification tasks. Using the support vector classifier, we will train the machine to classify product reviews into positive, negative, and neutral. The product reviews dataset contains 386 samples. This dataset is taken at the Kaggle website. The dataset contains two columns. The first column has a label review, where it contains now 386 different reviews of a certain product by customers, alongside with the second column with a label sentiment that indicates now the emotion and then the mood of the customer regarding the product that they bought. And then we can read here that there are positive sentiment, neutral, and negative. So therefore, the sentiment column is the target variable that contains three values, namely positive, negative, and neutral. The column review is the independent variable X. The column sentiment is the dependent variable Y. This dependent variable Y is also called target variable, outcome variable. In the Python code, we import the pandas and sklearn or scikit-learn libraries. Next to that, we are going to load the dataset from that given CSV file that has a name product underscore reviews.csv. CSV stands for comma separate values that it can be read by a text editor and Microsoft Excel. And using the pandas library, we will going to load all those 386 samples into the memory of the computer, and it will be stored in this memory variable reviews. After that, we will going to set the the features that we wanted to be included in the training data set. So the column review or the independent variable X will be selected as one of the feature, and it will be stored to a memory variable features. Another feature is the dependent variable Y or the target variable sentiment, and then it will be stored to the memory variable labels. So 386 reviews will be stored to the variable features, and then 386 sentiments will be stored to that variable labels. In this Python code, we prepare to train our machine to learn from the given product reviews dataset. We split the 386 samples of product reviews into 80% training size and 20% test size. The variable features contains the product reviews is the independent variable X, while the variable labels contains the sentiments such as negative, neutral, and positive, which is the dependent variable Y. We pass the arguments of both the two variables, features, and labels in the method called train underscore test underscore split. Next, we convert text into numbers using the class TFIDF vectorizer. The TFIDF vectorizer creates a dictionary from words provided to it and generates a matrix containing term frequency inverse document frequency values between 0 and 1, reflecting the relative importance of those individual words. In this command, we instantiate an object named classifier using the class SBC. This is the support vector classifier model. Next, we train the machine to learn from the given product reviews dataset by calling the method fit. After the training, we determine the performance of the support vector classifier model. When we run this Python code, the support vector classifier model accuracy is 96.15%, which is very high. This is the performance of the model during the training. After the training of the machine, let us test an example product review and predict its sentiment. The example product review is, the product is amazing. We convert the text into numbers using the command vectorizer.transform. And then finally, the converted text into numbers is passed as argument to the method called predict. When we run this Python code, the predicted sentiment is positive. Product review. There is another way to implement sentiment analysis, that is binary classifier, called logistic regression. Logistic regression is a special case of regression analysis, and it is calculated when the dependent variable has dichotomous or binary or two values only. The logistic regression uses the sigmoid function, which is an activation function that the predicted probability will fall from 0 to 1 only. 0 will be the lowest result and 1 will be the highest result. 1 will now be the positive and then 0 will now be the negative. Since logistic regression need to have a dependent variable values that has only two values only. Two values like positive or negative. Using the logistic regression binary classifier of the scikit-learn library, we will train the machine to classify movie review into 0 or negative and 1 or positive. The movie reviews data set contains 50,000 samples. This data set is taken at the Kaggle website. The first column of the data set has a label text that it contains 50,000 movie reviews from movie televiewers or movie goers, those who watch movies. The second column has a label sentiment, and then it contains either 0 or 1. 0 means negative, 1 means positive. The first column, which is the label text, is the independent variable X. The second column, which is the label sentiment, is the dependent variable Y, containing binary or dichotomous or two values of numerical values. The condition of logistic regression is that the target variable or the dependent variable Y must be two numerical values, not categorical data or text values. In the Python code, we import the pandas and sklearn or scikit-learn libraries. After that, we are going to load the dataset from the given CSV file, whose file name is movie_reviews.csv. So those 50,000 samples will be stored into the memory of the computer to this memory variable named reviews using the panda read_csv method library command. The command count vectorizer converts text into numbers and generates a matrix of word counts. In addition to that, the count vectorizer converts text to lowercase, removes stop words, and punctuations. Next, we select the column text from the product reviews dataset as the independent variable X, while the column sentiment will be the dependent variable Y for our feature selection. In the count vectorizer, we need to set the parameter min_df to 20 so that it will ignore words that appear less than 20 times in the corpus of training text. This will help to solve the problem of out-of-memory errors because the dataset is very large, 50,000 samples. In addition to that, the count vectorizer will, will convert the text to lowercase, remove stop words and punctuations, and then it will create a sparse matrices of counted frequency of words, which are matches to the built-in dictionary or the corpus. In this Python code, we prepare to train our machine to learn from the given movie reviews dataset. We split the 50,000 samples of movie reviews into 80% training size and 20% test size. We pass the arguments of both the two variables x and y in the method called train_test_split. The variable x contains the movie reviews, which is 50,000, while the variable y contains the sentiment values of 0 or 1, which is also 50,000 samples. Next to that, we instantiate an object named model using the class logistic regression. This is the logistic regression model. The argument max_iter set to 1000 passed to the call of the method logistic regression. We set the maximum level of iteration to 1000 so that it will not receive an out-of-memory error because the dataset has 50,000 samples. We train the machine to learn from the given movie reviews dataset by calling the method fit. After the training, we determine the performance of the logistic regression model. When we run this Python code, the logistic regression model accuracy is 88.68%, which is high. This is the performance of the model during the training. After the training of the machine, let us test an example movie review and predict its sentiment. The example movie review is, the movie is a spoof and a copycat. We convert text into numbers using the command vectorizer.transform. Finally, we convert text into numbers is passed as argument to the method called predict probability from 0 to 1. When we run this Python code, the predicted sentiment is negative. The probability is 0.42. I set the predicted probability of 0.60 and above as the positive, and below 0.60 will be predicted as negative. In your case, you can change this decision making. If you want 1/2, 0.50, therefore, it is up to you. Another example movie review to predict its sentiment is, the movie is boring. the predicted sentiment is negative. The probability is 0.14. Another example movie review to predict its sentiment is the movie has an amazing full of actions. The predicted sentiment is positive. The probability is 0.79, which is greater than the cutoff of 0.60. That makes it positive. Here are some of my ideas to share. Number 1. Use the pre-trained Bader sentiment analysis of NLTK library when you do not have dataset to train. It will provide instant text analytics in your application. Second, apply the support vector classifier of scikit-learn library when you have dataset to train and the target variable contains neutral, negative, and positive sentiments. It is not the case that it must be 3 sentiments only. It can also be more. For example, your sentiments can be sad, happy, angry, hurt, and so on. Last, apply the logistic regression of scikit-learn library when you have dataset to train and the target variable contains only binary or 2 sentiments. The 2 sentiments must be numerical values or numbers, not text or categorical data.
That ends our topic for today. I hope you are inspired in my class. Thank you for watching. God bless us.